Hello students, in this video we are going to study about aldol condensation. This reaction is nucleophilic addition elimination reaction. Why this is called addition elimination reaction? Let's see. So in case of aldehydes and ketones, those contain alpha hydrogen atom, at least one alpha hydrogen atom containing aldehydes or ketones undergo aldol condensation reaction. So what is meant by alpha hydrogen atom? Let's see. If we take the example of acetaldehyde, so formula of acetaldehyde is acetaldehyde CH3CHO. In acetaldehyde, CHO is the functional group, and if to the functional group, this is functional group, and to the functional group the directly attached carbon atom CH3 is attached to this functional group and is nothing but alpha carbon. Now if I can write this CH3 in its structural form, so 3 hydrogen atoms attached to this carbon, which is further attached to the functional group. Now if you observe, this is the alpha carbon, and to which these 3 hydrogens are attached are alpha hydrogen atoms. So what is meant by alpha hydrogen atom? The hydrogen which is attached to the alpha carbon atom. So what is meant by alpha carbon atom? The carbon which is directly attached to the functional group called alpha carbon, and to this alpha carbon the hydrogens attached directly are called alpha hydrogen atom. So those aldehydes or ketones contain at least one alpha hydrogen atom. They undergo aldol condensation reaction. So how the aldol condensation reaction takes place? Let's see. If we take the example of general example of aldehyde RCH2CHO. So this is the aldehyde in which this is the alpha carbon atom to which these 2 alpha hydrogens are attached. When it combines with other alpha hydrogen containing aldehyde, and this reaction is takes place in presence of dilute alkali like NaOH or dilute KOH, or in presence of sodium carbonate. Now what happen during the reaction? This RCH2, I can write this CHO in its structural form. When it combines with other RCH2, I can write this CH2 like this way, and CHO group. So these are 2 aldehydes. And how the addition takes place? Let's see. In this second aldehyde, CHO is the functional group, and to this functional group the directly attached carbon is nothing but alpha carbon, and to which this hydrogen is attached is nothing but alpha hydrogen atom. Now the addition of alpha carbon atom is always takes place to the carbonyl carbon, and alpha hydrogen is added to this carbonyl oxygen, and this reaction is takes place in presence of dilute alkali like NaOH, dilute NaOH. Now what happen? Addition takes place. We get the intermediate product RCH2 as it is. To this CHO group, this CH as it is, O is converted into OH, and it is further bonded with this alpha carbon is nothing but CH, to which this alkyl group is attached, and further it is bonded with the CHO group. Now if you observe, this is the intermediate product formed. Now this CHO is the functional group. I can highlight it by the using green color. Now to which the first carbon attached is alpha carbon, and second carbon is nothing but beta carbon. Now to this beta carbon, this OH group is attached. So therefore this compound is called beta hydroxyaldehyde. So generally the name of this compound is beta hydroxyaldehyde. Again, if you observe, in this compound two functional groups are present. CHO is nothing but aldehyde and OH is nothing but alcohol. So addition of both these compound, for aldehyde ALD prefix is used, and for alcohol, that is OH group, the suffix OL is used. So the name of this compound is, generally this compound is called aldol compound, because it contains both the functional group, two functional groups. One is aldehyde and other is alcohol. So the name is given to this compound is aldol compound, or it is also called beta hydroxyaldehyde. Now what happened? When this beta hydroxyaldehyde further undergoes elimination reaction, so after heating it undergoes condensation, that is removal of water molecule takes place. So removal of water molecule takes place from alpha and beta carbon atom. So from alpha carbon atom hydrogen is replaced, and from beta carbon atom this OH group is replaced. So from alpha and beta H2O molecule is replaced, and this single bond is converted into double bond according to its valency. So what do we get the product? Let's see. Is RCH2 as it is, CH double bond CR further bonded with CHO. Now here we get two functional group containing compound. So this CHO group and doubly bonded means alkene and aldehyde group containing compound is formed, and the H2O is replaced from alpha and beta compound, beta carbon. So alpha beta elimination, so water molecule is eliminated from this intermediate compound, so we can write here plus H2. So generally this compound is called as alpha beta unsaturated aldehyde. The name of this compound is alpha beta unsaturated aldehyde. So this is about the general example of aldol condensation. So if you observe here, CHO is the functional group, and to this functional group the carbon attached is alpha carbon and second one is the beta carbon. So alpha beta elimination, from alpha beta carbon water molecule is replaced, and therefore this compound is generally called alpha beta unsaturated aldehyde is formed, and this is the aldol condensation reaction. Actually what happens when the reaction takes place? Suppose we take an example of acetaldehyde. So formula of acetaldehyde is CH3CHO. CH3CHO, this is ethanol or acetaldehyde. So when acetaldehyde or ethanol undergoes aldol condensation, means the reaction takes place with another molecule of acetaldehyde. So I can write this CH3 is HCH2 form to show the addition reaction. Now what happened? This hydrogen is added to this carbonyl oxygen and this alpha carbon is added to this carbonyl carbon. So what happened? What do we get the product? Let's see. This reaction is takes place in presence of dilute alkali like dilute NaOH or dilute KOH or Na2CO3. Now the addition product is formed is nothing but CH3CH as it is. This doubly bonded O is converted into singly bonded OH. Further it is bonded with CH2CHO and the name of this compound is, so this CHO is the functional group of aldehyde and this is the alpha carbon, second carbon is beta carbon to which OH group is attached. So beta hydroxyaldehyde or its IUPAC name is, if the IUPAC name is given to this compound, then we number this chain from the carbon which gets minimum possible number to the CHO group. So at position 3 OH group is attached, so 3 hydroxy and 4 carbon containing straight chain of aldehyde butanol. Okay, 4 hydroxy butanol is formed and when it undergoes elimination reaction after heating, alpha beta elimination is takes place, means one hydrogen from alpha carbon replaced along with this beta carbon containing OH group. So removal of H2O is takes place and we get a final product, and the final product formed is nothing but CH3CH double bond CH-CHO. The name of this compound is crotonaldehyde. Crotonaldehyde is the common name and its IUPAC name is, this is a 4 carbon containing chain, so but 2 in Al, butanol or but 2 in Al is its IUPAC name. Okay, so this is about the aldol condensation. It takes place in the aldehydes or ketones, those contain at least one alpha hydrogen atom, then only they undergo aldol condensation. So in the first step it form beta hydroxy compound and in the second step it form the unsaturated aldehyde. So this is about the aldol condensation. Now if we take the example of ketone, so when acetone is treated with, formula of acetone is CH3COCH3. When acetone undergoes reaction with other molecule of acetone, so I can write this CH3HCH2 to show the addition reaction. I can write this H separately. This is the functional group of ketone, CO group is the functional group of ketone, and to this functional group directly attached carbon is nothing but alpha carbon. Now this alpha carbon to which hydrogen is attached is nothing but alpha hydrogen, and the addition of this alpha hydrogen to the carbonyl oxygen and alpha carbon to the carbonyl carbon. This addition takes place in presence of dilute alkali like dilute NaOH. Now what happened? Addition product is formed and the formula of this addition product is CH3CCH3 as it is. O is converted into OH, further bonded with CH2COCH3. Now if you observe, this is the functional group, and to which the first carbon attached is alpha carbon, second carbon is beta carbon. So this is the alpha carbon and this is the beta carbon. To the beta carbon OH group is attached, therefore generally this is a beta hydroxy ketone. And if you observe, in this compound two functional groups are present. One is the ketone, other is the alcohol, and therefore generally this compound is called, for ketone KET prefix is used, and for alcohol OL ending is used. So generally this is the ketol or beta hydroxy ketone. And when it undergoes further elimination reaction, before that, what is the name of this compound? See, the IUPAC name of this compound is, if we number this straight chain from the side which gets minimum possible number to the ketonic group, then at position 4 OH group is attached. So the name of this compound is 4-hydroxy. To this fourth carbon atom, this methyl group is attached. So 4-hydroxy, 4-methyl, 4-hydroxy, 4-methyl, and at position 2 this ketonic group is present, and 5 carbon containing straight chain. So pentane, 5 carbon containing alkane derivative pentane, at position 2 ketonic group, so 2,1. So this is the correct name for the given intermediate compound, 4-hydroxy, 4-methyl pentane 2,1. Now when it undergoes elimination reaction, so after heating it undergoes alpha beta elimination. So from alpha carbon atom hydrogen is replaced, so from this CH to this hydrogen is replaced, and from the beta carbon OH is replaced. So removal of water molecule takes place and we get the final product. So what do we get the final product? Let's see. CH3, CH3, C, CH3 as it is, double bond CH, CO, CH3. The name of this compound is, common name of this compound is mesithyl oxide, and its IUPAC name is, to give IUPAC name we can number this chain which gets minimum possible number to this ketonic group. Now at position 4 this methyl group is attached, so the name of this compound is 4-methyl. At position 4 methyl group is attached, 4-methyl, 5 carbon containing straight chain, so pent. At position 3 double bond starts, so 3En, and at position 2 ketonic group is present, so pent 3-in-2,1. So this is the IUPAC name for the given compound, and this is the final product which is formed from the acetone when it undergoes aldol condensation reaction.